You can start recording if you like. All right, welcome everybody. So happy for you guys to join me, especially after lunch. So this is my session, 3D printing remotely with Tinkercad. My name is Judy Nguyen. I have my lovely co-facilitator here with me. His name is Pete Nguyen.
He's called me lovely.
You're very lovely to me. And so yeah, let's get started. Awesome, Lisa. I hope this covers what you're interested in learning about. So I just have some few questions in the beginning. That's what I consider introduction, some warm-ups. I'm going to go over 3D printing 101. Hopefully it's not too beginner, but I always feel like it's really nice to just give a brief introduction. Quickly discuss the educational benefits of 3D printing. And then I'm going to go into the resources for managing a remote 3D program based on my experience this last year. And then I'm going to give you a case study from St. Peter and St. Paul in Upland, California, where how we were able to manage this remotely. In the corner, I think it's covered right now, but my bit.ly for the resources, it's bit.ly/Judy. And then all caps ARVR3D. It's just a website with all my resources. Look for the page that says 3D printing and building with Tinkercad. So all the resources that I mentioned and more are here.
See what Lisa said?
No, what did she say? Oh, you got a 3D printer during COVID? Oh yeah, okay. Lisa, what kind of printer did you get? Do you know?
You know what? I'm not even sure. It's still in the box.
I know. That always kills me when it's in the and it happens too often. It's
well, ours is because everything arrived. Our whole makerspace arrived during COVID. So
oh man.
Yeah,
like,
our kids
yeah.
have seen a video of it and pictures, and they're dying to use it, but I don't even know if we're gonna be able to use it when we go back.
Okay.
So
you know what? If you need help, call me later, and I'll be happy to work with you.
I'm following you on Twitter already.
Okay, thanks. But yeah, if you want to, I usually do a Slido, but I feel like let's just keep it chill with the chat. But if you want to explain your role, who you are, what you teach, feel free to add that in the chat. It's always nice to know where you're coming from. You know, with Tinkercad, it's mostly for like kindergartners use it, but I would say 3rd grade to 8th grade, because most times if there's engineering or some kind of design class in high school, they're probably using Autodesk or Onshape. But Tinkercad, it's like all ages. I'm very happy with Tinkercad. I feel like it's right up to my level, and so don't feel like you're limited to that grade. But if you want to share what's your role, what do you teach, that'd be great.
I just tried to open that link and I couldn't. It says I needed to access.
For the bit.ly?
It was in the chat.
Yeah, so put HTTPS.
Oh, okay, my bad.
And then Judy ARB3, yeah.
That work?
Try that. Yeah, that
Thank you.
Should work, yeah.
Yep, thanks.
And then if you would let me know, and feel free to unmute too. I'm so used to just talking to myself. So it's always nice when I hear a voice. So I'm like, oh, somebody's responding. But if you want to share how familiar you are with 3D printing, do you have, basically I want to figure out who's the experts here, because that's who I rely on, like to chip in or to pitch in the conversation. But if you're a beginner, it just helps me to know, to gauge like how, like I don't want to go so fast, so much into the beginning if most of you guys are kind of experts.
I'm a beginner. I've only printed a couple of things.
Okay. All right. Thanks, Lisa.
And it was files that already existed.
Yes. And that is like that's where I started. And I'm not even like an expert. I'm still, I'm more like the facilitator for 3D printing, and I get everybody else to print or to design. Okay. Yeah. SketchUp. The junior high, yes. SketchUp is really good for 3D design, like interior decoration, but it does have a component for 3D printing. Okay.
I've just been to a training, but I haven't done it with my kids yet.
Oh, okay.
I'm ready to jump in. I'm just haven't started yet.
Yeah. And so it kind of, yeah, with Tinkercad, it kind of, there's a lot of resources, and I'll share with that later. And then with your 3D printer, you're going to have to kind of see where it's at. Like there's different models. And if your school purchased one that's probably like $800 or more, most likely it's enabled for wireless printing. And I'm going to talk about that. And if it's not, you could still do this remotely, because the idea is to get the students to design. And thankfully, Tinkercad is web-based. So as long as they have a Chromebook or access to a browser, they're good.
So
yeah.
do they send you a file or to print, or do they remotely send it to the printer?
They send me the file. They send the teacher the file, and I'll explain that process of how we organize
Perfect.
it.
Thank you.
Yeah.
I'm jumping ahead.
Yeah, you are. It's fine. It's fine. I'm like, oh, people. Okay. So,
You said just made me question that. So.
No, you could do it. No, yeah, we're jumping ahead. It's not bad. Like you could do everything wirelessly, but also if the printer requires an STL file on a thumb drive, you could still, at least from the student's part, it could be all done remotely. And okay, J Mark, thank you. So you're using, you use SketchUp too. Yeah, SketchUp for education works really seamlessly with Google. So it totally makes sense to use SketchUp, because it's really easy to just add that. Okay, anybody, so Lisa, you said you had plans, like all this STEM things showed up during COVID, but what was the idea for, like, what was the intention behind purchasing the equipment? Oh, you're on mute, honey.
To create a makerspace for our students so that they could, we're thinking more around the idea of design thinking, right? So they can create their own items, but we haven't had any training as far as Tinkercad or 3D printing or anything like that. So I need to get some background so I can teach my teachers.
Okay, sounds good. All right. I'll keep an eye on the chat, but if you want to answer more questions or have more comments, but I'll just move on. I always like to start with the brief history of 3D printing. There is a person, Chuck Hull is considered the founder or the inventor, although.
So what's it going to be? A custom pair of shoes? A new mobile phone case? An artificial tooth? Or a drill with your own brand on it? It's now possible to print all of these things using 3D printers. This is the father of this incredible technology, Chuck Hull. 30 years ago, this American developed the first method that would go on to revolutionize the industry today. 3D printers make it possible to create almost anything, even a miniature bust of the inventor himself.
When I invented 3D printing, I guess over 30 years ago now, I had lots of things in mind for it, but I just couldn't imagine all the things that happened in almost an industrial revolution.
The initial problem was a practical one. In 1983, Chuck had designed a few prototypes. He was working with plastics and UV light, and was always annoyed by how long it took until the first draft was in the designer's hands.
Prototyping plastics was a really big issue at the time. It took lots of weeks, even months, between when an engineer had a design and then the first prototype. So it was a big problem that I tried to solve. So that got me into experimenting and trying to figure out how to do 3D printing with these kinds of materials and ultraviolet light.
Back then, there was no way anyone could have predicted that such elaborate objects could be produced. The first object that Chuck Hull printed was rather simple. An eye cup used by optometrists.
So I always like showing that video, especially to students. It's just so where it came out of. It's a definition of problem-based learning. He had a problem. The prototypes that he was trying to create just took too long, and so he ended up creating the foundation of 3D printing. And in that video, like this.
So what's it going to be? A custom pair.
This printer is like 30,000. It's an incredible 3D printer. from 3D systems. It uses a material like it's like plaster of Paris. So this is not what our students are going to be using, but it's really interesting, like what other type of 3D printers out there. We've probably seen the videos on YouTube of the cement ones that some people are using to build houses. So it's really almost endless, the possibilities. You have steel ones. It's just a really neat skill that we could leverage, give to our students. If you watch the movie Black Panther, the queen, her headpiece, a lot of that was 3D printed because you're able to create something unique from that process. So it applies in different, so it's STEM, but it's also that art, it's also the other features and other topics. So let me go really quickly over the 3D printing process. So the first part is the CAD design. So you're going to design something, or you find the design that was, or the object that was designed in some kind of computer aided program, draft program. We're going to use Tinkercad because that's appropriate for our littles or our younger people or novices. And once it's designed, it needs to be converted to an STL. And so a lot of the programs will have their own file, but you have to export it to STL. And that's the most popular format for 3D printing. OBJ is also a good one. OBJ, if you're using SketchUp, you're probably familiar with OBJs because OBJs retains the color, but you don't need that for STL because the printers that we're using, unless you spent the money for that 3D system ones, it doesn't matter what color you design it in because it's going to print in the color the filament that you have. So that's why STL is the most popular, but OBJ is the second. You're going to send it to some kind of software. And I'm going to show you some options for online slicing tools. It'll slice it. So it takes that design and kind of like Legos or like slicing a cake. It figures out how to print it layer by layer. So it slices. And then you have to set the machine up. So some machines take a lot more work than others, but you level the building plate, you put in the filament, you heat it up. There's all these little things that you need to do before you can hit print, and then it builds. And depending on your design, you might have to design a support. Like if you have an arm that's 90 degrees, it can't print that way. It needs a support. And so the post-processing is the removal of that support. So it just depends on the designs the students created. And that's something you have to talk about with your students when you're getting to design is it might look really great on digitally on your Tinkercad, but if you're going to print it, there's some things that either they have to build or the printer can actually help with that. And then there's post-processing, sometimes cleaning up, filing things down, gluing things together. You know, I was in a big Baby Yoda phase, so I was looking for all these Baby Yoda files, and the one that I really liked was him holding a cup, but it was 3 parts: the head, the body, and the cup. And it was a little bit annoying because the cup wouldn't stay. So, but that's the post-processing, the gluing or putting things together or cleaning things up, and then applying it. In my case, the Baby Yoda was something decorative, but there's tools or helpful pieces and how you're going to use that. And that's the processing in a nutshell. And is there any questions? We're good. Okay.
Are these slides also in that link of yours, the bit.ly?
No, I just put the resources in there because I keep changing this presentation. But if you want it, just reach out to me and I could send it to you.
Okay, I'd love it. Thanks.
Okay. So some terminology. CAD, as I mentioned before, Tinkercad is a version of that. Autodesk, Onshape, even SketchUp. It's a computer aided draft. Filament, these spools are filaments. So it looks like spools of thread. That is a PLA, and that's the second term. That's the polylactic acid. It's starch based, so it's plant material. And that's important because we don't want to pass out in the classroom when the 3D printer is going on. You don't want to get poisoned with the fumes. And so the fact that it's plant-based, it deteriorates, so it's safer to use. There is a little bit of a smell, but it's not dangerous. And it's the most common, and it's most likely the filament you're going to use unless you buy or your school has bought a 3D printer that allows multiple types. ABS is another one. There's nylon. They're a little bit stronger. The print could support more weight, but they could also smell because there's more plastic in it. So you might want to find something that's eco ABS, or just make sure there's a lot of ventilation. It's just something to, if you haven't bought a 3D printer yet, just something to look into. But for beginners, I would say everybody starts with PLA. It's the most affordable, and it's the easiest to work with. And then STL is the file. That's the file extension that you're looking for, that you'll need to import it to your slicer to slice it and get it ready to print. So what are the benefits? And so Lisa was talking about, they have the attention for this makerspace, design thinking, problem solving. And so how it benefits, I mean, it creates excitement. I don't know if you remember the first time you saw a 3D printer, it was pretty exciting. I still get excited when I see things print, when I get to that process. And so it builds up that excitement with students. It does complement the STEAM curriculum. And I'll show you the Tinkercad lessons. Those are lessons that Tinkercad has created. They just released them, I think, over the summer, complement STEAM, and just the idea of problem solving and using their math skills or science skills, engineering, and the artistic too is really important. So that it all goes together. What's also really neat is that there are resources out there where you could print things that you couldn't have access to before. You could print artifacts. The Smithsonian has a whole STL library of artifacts that they've scanned, and then you could print. There's a story, I think it's LAUSD, maybe one of you know that teacher. There's LAUSD, there was a teacher that had a student that was blind. And I think they were talking about cows or some kind of animal. And the student had no reference for that. So he 3D printed a model of a cow, so he had some kind of context for the story. So things like that. And just the opportunities for learning, and it really does promote problem solving skills. And I'm going to give you a quick example, and this is in the website. There are 2 lessons from my STEM kits that they offered for free that had a design component. And it's how to design the best wind farm blade in Tinkercad. And it's a great lesson. It's when I taught it or co-taught it is with 6th, 7th, and 8th graders. The math is more appropriate for 8th graders, but we were able to modify it for 6th grade, because the first thing they had to do is find the area. So this is a blade that came in the lesson. So I printed that blade. So another materials that you probably wouldn't easily have access to. You could just print it. So I printed this blade for them. I printed like several sets. There's another one here. It's kind of hard to see. I really love this black filament. It just comes out so nice. But they had to figure out the area. And this was actually pretty challenging. They understood the formula, they understood the math, but wasn't a perfect rectangle or wasn't a perfect square. And so they had to problem solve on how to find the area. Because one of the things the challenge was, how do you find one that has less mass, isn't as heavy, so it's less expensive to print, but also generates a lot of energy. And then this was one of the tests. They had to measure, and they had to measure how fast it could lift that level. And we were doing this several times, and I should have muted it, but here. We did this several times, and it was so fast for the human eye to catch how long. So they figured out, oh, let's record it with our iPads. And then we could slow it down and see how many milliseconds it took for it to lift. And so, so they did that. I'm like looking at the chat, what's going on there? Okay, and then they did that several times because they had to measure. So, and then they designed their own blade based on the information that they gathered. And then they had to test their blade to see how fast it was. So that's something that's in here under lesson ideas. And it's also, I think I put the PDF. Yeah, they're right here. So they're there for you to access. So let's talk about resources to support 3D modeling and printing remotely. I'm going to take a breath. Is there any questions?
There's some lessons in there for younger kids also, like second, third grade.
Yes. Let me double check. When we get to Tinkercad,
Okay, thanks.
we'll look for that. There's really good ones in Tinkercad that I liked. So the first thing is we use Tinkercad. Why? Because it only requires a web browser. It's also at the students level. So the students that I have been working with, I'm not in the classroom anymore. I'm a consultant that works with teachers. But the grades that I had been working with primarily have been the 6th, 7th, 8th grades. And so Tinkercad works great for that age level. The schools that I have been working with are using Google Classroom, and Tinkercad has a way to work with Google Classroom. They also have their own classroom. So if you're a school that's not using Google Classroom, they're using Seesaw or something else, they have its own classroom that you could create. And then it's a little extra steps because you have to create the login for them and they log in. But it is something that you could do and that you could see their designs. You need a system for collecting student designs. So the first one's a freemium. So this is Polar 3D. Polar 3D, and I'll show you when I get to Tinkercad, there is a way to export directly to Polar 3D. And if you have an education account, it is really easy for the students to send it to Polar 3D and to create a queue and for you to print it. But it costs money to do that, to have that kind of system in place. But if you just have your own account, so this is just my own account. I'm not in a school. If I was in school, I'd have more options. But this is a slicing software. And I've also, so I have 2 Dremels. I have a Dremel 340 and a 45. So I've connected this to one of my Dremels. You can see that's offline. And these are the prints that I've uploaded and sliced. And so when I go online, I could just print this remotely. And I'll show you how I got those prints from the students. The other one is 3DS, 3D Printer OS. Your printer might already have a relationship with either of these, the Polar Cloud or 3D Printer OS. Because I'm going to show you that my printer, the Dremel, does already have the software included. So I didn't have to go buy it or anything. It was included. If you have MakerBot, it's probably included. So make sure you read all the literature that has read all the literature that is included in your 3D printer to see what software is included, so that you can do that. And then we created a form. So this is a form that we created. So go ahead. Do I know about Ultimaker? I don't know about Ultimaker, but I think there's a link here, and I want to say it's here. There's a whole list here of what their Robo 3D. Yeah, there's a big list that they're already supported. So I would check that out and check. Ultimaker probably has it in the literature that came with the printer. This form, we created this form to put into Google Classroom. And so the form has a first name, last name, filament color, and you could just take that out, but you can ask them to request the color or take it out, because then don't give them that idea. If you have very limited filament and very limited options, then don't give them that option. You could, if they have access to Polar Cloud or some other software, like a slicing software, they could estimate how long it will print. But then again, you could take out that question. I think the teacher that I worked with, he took out that question, he took out the filament. And this is the most important, upload the STF file. They need to upload the file. So these are STLs. This is 3D object that I'm on a PC. Yeah, you need to upload the STL file so that the teacher can get it. And if you're familiar with Google Forms, the output is an Excel sheet with their name and the STL file that the teacher can download and then upload to the slicing software. I found this website that I thought was really neat. You don't have to include this, but if they're old enough, you might want them to kind of see how much this would cost. If you're going to charge them, I know some schools, probably more like the private schools and the public schools, might say, yeah, we'll print it for you, but it's going to cost you this much. Or this might be a service that you'll do in the library and go, yeah, we'll print it for you as a service, and this is the cost. And so maybe you don't share this with the students, but you do this yourself to see how much you could charge them. I just thought it was really neat to give them the idea that this isn't free, that it does cost money, but obviously you don't need to include it. The most important parts of this form is the first name, last name, and upload STL file. Another question you could probably add is the description and name of the file. So, or anything else that helps you organize the assignment. I hope that makes sense. And then a system for setting up the queue. So yeah, Ultimaker, look and see what software is included. If you have Polar 3D Cloud, either your personal one or your school has bought one, it's even better because it's going to make it easier. If you have 3D Printer OS, that's going to be good too. Okay, so this is the example of how we did this over the fall. So this is October of last year. St. Peter and St. Paul, they want to do a lesson in Tinkercad, and the project was a bubble wand lesson. They were 100% virtual remote learning program. So the teacher was reporting to campus, but all the students were joining remotely. They used Google Classroom, and the teacher only had, I was surprised, I don't know about you guys, but I was surprised that he wasn't the only teacher that I worked with that only had 30 minutes. All his classes were 30-minute meetings on Zoom. And I was a high school teacher, and I had 83-minute blocks. So 30 minutes, I'm just warming up. So I don't know how he was able to get anything done with 30 minutes, but we had 3 sessions. So the first one, it was the 3D printing overview. It was that video I showed. I taught him the vocabulary, and we had a discussion. I think I showed him another video of some students of what they were able to accomplish. The second lesson was Tinkercad. So we had them log into Tinkercad, create their accounts using their Google school email address. And the last lesson was the modeling, the bubble lesson. And they did all their designs at home, and they sent their designs to the teacher using this Google form. And then the teacher downloaded all the STL files and printed them. And so this is an example of, this is my Dremel. And this is the Dremel 3D Builder, but this is 3D Printer OS. This is the operating software, and with the printer. So this software works with different printers, like I mentioned before. If I go to my dashboard, they're both off right now, but this is like how many hours I printed, how many prints, how many errors. If I go to printer, you can see I have 2 printers. I've named them. So if you're a school, this is what's nice about having a similar product like this, either on Polar Cloud or this, is that if you have 4, 5, 6 printers, you can name them so you can keep track of how they're doing. And then there's nothing in the queue right now, but it would tell me what film I'm using and how long it would take. And what's nice about this one, it does have a camera built in, so I could always pop check to see how it works. There might be other ones that do that too. So let me kind of walk you through the process. Once you have the STL file, you upload it. Once you upload it, so these are the ones I've uploaded, but I haven't sliced it. So I have here, yeah, here's my baby Yoda in a crib that oh, there was an error, so I'm not going to do that one. So then here's a bucket. Oh, it was Halloween, so I was doing like tea light holders. So it's STL, it's ready. Here's the size. I'm going to click on repair, and it's going to be different for different software, but this one does a magic fix. And I could either pick 3D45 or whatever printer I have. and then layout. So it's going to be different. How do I say it? It's similar process no matter what slicing software you have to figure out the layout. And this is where, as the teacher, this is why I don't like the students sending directly to the printer, because especially if you're a new program, is that you're not going to print this. This is going to take a week, 2 weeks. It's going to take several spools. This is too big, and it's bigger. So you have to resize it so that it's so big that I can't even and move it right now. And that's how you get to preview it before you even print it. So let me go back. And I'll show you my other projects where I did print them. So this is an example of where I had sliced something and then I created a layout. And so you can see here, I've made it small, but I've also copied it or duplicated it so that I could print 3 at once. So this is like the teacher organizing the print queue. I chose 3 of the same, but I could have 3 different prints and just print it at once and then come back later. Any questions? Does this make sense?
I have a question. You can,
Okay, Lisa first and then Stephen.
sorry, Stephen. When you said you can print more than one at once of the wand or whatever, could you just take each of those files that the kids sent you and lay them down next to each other? Is that what you're doing?
Yes.
Basically?
Yeah,
Okay.
this software, and it's almost the same here as far as the layout, although I'm only you just kind of pick the angle. And there's like a rabbit here. That means I could copy it. And then